Should be live. Welcome, viewers. Congratulations on realizing this channel exists. It's only the world's most comprehensive daily space weather content. Save the propaganda for a different channel. So today we'll briefly talk about how the space weather hits came in exactly as forecasted. And yeah, they were glancing blows. So we didn't see the strong BZ component of the magnetic field that we would like to see a strong series of geomagnetic storms, but the hits came in nonetheless. So we'll briefly talk about space weather and earth weather and whatever viewers say that's relevant to anything in the comments. So thanks for tuning in, those who have. If you're viewing in syndication, leave us a comment. Don't forget to press share, like, etc. And visit the homepage at smashomash.com to find where we are on social media. And it's all over. Social media is where. Social media. We are also on the Don't Die app, which is social media. You see, Don't Die doesn't require quotes. It really is social media. Isn't that amazing? Unlike social media. You understand. I'm sure you get the difference. So yeah, let's talk space weather. I'm gonna bring you YouTube types to the studio after I disrobe a bit, as I just got back from a little outdoor stint walking Smash staff to work. If you're wondering what she does, she is a teacher. So I'll get the correct hat on here, which is this is the correct space weather hat for today. There we go. Got wardrobe told me that this is what I'm wearing, so there it is. You're welcome. All right. Yes. There we go. That's what you want. We'll tell you about planets in retrograde. Oh no, watch out, folks. Planets in retrograde. And I may look a little like Pippi Longstockings throughout the day. I'm going to leave the coffee for later. It's a little too hot to drink rapidly. I'll just do it after the stream. Which again, it's not going to be that long because it's early. So, may make a reaction video stream today. It's possible. There is certainly a lot of silly stuff on YouTube to react to. And of course, we know viewers are reacting to lots of stuff. Ridiculous thumbnails, ridiculous titles, ridiculous videos all around about space weather. I mean, so much nonsense. All right, so sweet, I'm already logged in. Look at that. That's special. Be right back. Don't forget to press the share button, folks. Just waiting for some web pages to load here. I'll be back in a jiffy. I'm not sure how long that is, but thanks for leaving a comment. Daniel Berry, Sports Highlight 5851. All right, so we're back, and yeah, happy Monday. Congratulations on surviving another weekend. All right, so the sun is actually pretty inactive right now. We don't have a huge sunspot number or anything like that. I was just showing you the ionized helium here. This is the 304 angstroms near real-time imagery from GOES 19. There's a big prominence there on the far side, as well as an active region rising here in the southeast. So right over here on this southeastern limb, a little bit of activity popping off, it looks like. And let me get your chats on the screen here. We are able to show those on the screen despite the guerrilla filming techniques. For some reason, YouTube and portrait mode like to go together. I guess a lot of people view the videos on their mobile device. So anyway, here are your chats. For those of you who viewed live and typed a comment. All right. Before we talk about Earth weather, let's go over the space weather essentials. And it looks like HelioViewer may be missing data here. All right, no, great. We do have the HelioViewer data available. Here's a close-up of that new active rising region. Let's look at 171 angstroms. There we go. Great view of that. If it is a sunspot group, it's probably not huge. But let's move on here. We'll skip cosmic rays today and X-rays and so on. Let's see if there's any new space weather on the way by looking at the University of Reading forecast. We're usually in fairly close agreement here. Although I would note that in this previous few days forecasting, we actually did a little better than University of Reading. So this is a normal thing that happens with space weather. It's not easy to forecast. That's part of the reason why we do it, because it's hard. It's far too easy to forecast Earth's weather, so forecasting space weather is an acceptable challenge. So it looks like there is, according to U Reading, nothing new on the way. But don't quote me on that because we got to actually check. All right. So the solar wind here is pretty nominal, it looks like. A little bit accelerated in terms of the velocity. Solar wind speed here over 500 kilometers a second. Had some little spikes here with more like 600 kilometers a second. But the field is pretty weak. It's a BZ of positive 9 with a total field of 9 nanotesla. Solar wind density here, less than 1 proton per cubic centimeter. So that's a coronal hole high-speed stream and a pretty slow and pretty unexciting coronal hole high-speed stream. Sunspot number here, all the way down to about 50 sunspots according to Royal Observatory Belgium. Space Weather Enthusiast dashboard. Is expecting some space weather basically right now. So we should be in geomagnetic storm conditions or have had geomagnetic storm conditions, but it looks like it was a glancing blow, not a direct hit. So as far as radial flux goes, it's 110 solar flux units as reported by Solon.info, solon.info/solar if you want to follow it yourself. It also shows great stuff like coronal holes and all kinds of solar data like the magnetic fields and so forth, flares. It's a pretty good website. You know, if you do stuff like keep track of coronal holes and active regions, it's got a great breakdown of the sunspots and other features. Next, the coronagraph. That's the great GOES 19 coronagraph, the brand new one. And we do indeed see some space weather popping off here. So we see some solar storms being launched. The question is, are they earthly directed? So that could be an earthly directed one. I definitely see a partial halo there. So fingers crossed. Earlier this morning, so right here, just before midnight Universal Time, there was indeed a CME that included a halo. So right before midnight. And then a second event just in the past couple of hours there. But let's look at stereo A and see if the data is available. If so, we'll be able to rapidly tell if that is earthly directed or not, because it will come out of the left side of the frame if it's earth directed, and the right side of the frame if it is on the far side. All right, so here we go. And sup with that. Doesn't look earthly directed to me. Looks like it's on the far side. But if it's coming out of the east, there could be an earthly directed component there. We'll have to wait for the models on this one because, look, the data is partially missing there at stereo A. So we don't see the initial blast off that CME, but I suspect it is not on the earth side. And the more recent one, looks like it's off to Earth's east. So I don't think those are earthly directed CMEs, those most recent ones. Next, the planetary locations. I like to use the planetstoday.com. I would remind our viewers that this is nowhere near to scale, and that's so that these things fit on the screen. This is their relative radial location. Just keep in mind, planets are really far apart from each other. Nowhere near those locations, again, as that is not to scale, not even close. But we do have Jupiter and Uranus in retrograde, so that means a thing to somebody for some reason. And look at that. Oh, noes, folks. Venus and Mercury are about to go into retrograde. Oh my God. Dear God, folks, we're going to have two retrograde planets at the same time, which means a thing to somebody for some reason. Astrologers or something. Proton flux remains flatline. No solar energetic particles of note. We did have a significant flare, and that was associated with that CME. There you go. It was an M3.38 class solar flare. We're going to see how that affected things momentarily. But first, the heliosphere. Yeah, the magnetism of the heliosphere. We'll actually put up 2 days here. Here's yesterday plus today, as Earth is just about to leave this South Pole-oriented magnetic sector, cross a current sheet, and then another current sheet, and then into a North Pole magnetic sector. Why is that? It's because the field lines are pointed the opposite directions, folks. These field lines are pointed toward the sun. These field lines are pointed away from the sun. That's North Pole over here, Earth, just leaving this South Pole magnetic sector. And no, it can't be used to forecast earthquakes. If it could, people would use it to forecast earthquakes. People aren't idiots. Tsunamis are dangerous. So here is our line of sight coronal hole plot. And you can see these North Pole oriented coronal holes here moving in as Earth approaches that current sheet and indeed sector boundary crossing and the other current sheet. Here's a space weather joke for you, folks. Ha 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 ha. All right, here's one. Maybe you'll be able to get it. Put it in the comments. Why did the planet cross the current sheet? Anybody? Anybody? The punchline is to get to the other heliospheric magnetic sector. Of course. Why else? All right. So, yeah, there's that. Coronal holes, folks. You'll see plenty of them for years because they're a feature of the solar cycle. These are the polar fields. They will eventually fixate at the heliographic poles. So this will, at solar minimum, this will be all green down here, and this will be all red up here. That's what happens at solar minimum. enduring coronal holes hang out at the heliographic poles for an extended period with few to no sunspots. Solar minimum. It's coming. Give it a couple of years. A couple of years. Next, looking at the magnetic fields here, and that is what's going on. There's yesterday plus today from Cerro Tololo, Chile. We see indeed we do have some sunspots here kind of directly oriented toward the Earth. And thanks for leaving a comment, Kenneth Small. Good morning, as we gaze at the most interesting star of all, the local yellow dwarf. Here's red light. So pretty inactive here, and we do see some growth. We see some growth in this sunspot group up here, but the rest of these are looking pretty stable. In fact, some degradation of this group, it looks like. Let's just bring up the last image. There's the latest from Cerro Tololo, Chile. Yeah, so some growth up here, some degradation down here. These look magnetically complex, so if we go back to the magnetogram, bring up the last image, there is a little bit of magnetic complexity there. That's a good thing if you like flares and coronal mass ejections. Next, we'll look at filaments. These dark absorption features that you see here, these are filaments. They are blocking the hydrogen alpha signal from getting to the ground-based observatory there in Chile. And you can see a number of dark features here on the Earth side of the disk. So that's a good thing. And it looks like there is a CME in progress. So right here at the end, you can see this one popping off. The Sara-Husial filament is mostly ejected. And I think that CME may have an Earth-directed component. So it's a bit stealthy there, considering the missing data on stereo A and so on, but sometimes you have to use the process of deduction. I suspect some of that ejecta is earthly directed, so another CME impact can be expected here early in the day on the 15th or late in the day on the 14th. So that would be Wednesday evening into Thursday morning. Wednesday evening into Thursday morning. Moving right along. Don't forget to follow us on X if you want to name filaments after your friends, your foes, or even yourself. Follow us over there on xx.com/smashomash. The electron flux still showing some electron storm conditions here. We came out of electron storm and then right back into electron storm as forecasted on Friday. On Friday. Yeah, there we go. Electron storm has returned, and that's because a bunch of space weather has impacted. So the F layer is doped. The F layer is doped with charged particles. And we're talking about this part right here. The F2 layer is where we prefer to measure that. Keep in mind this does vary in altitude quite a bit, as the F region is about 300 kilometers at nighttime, and the F region goes all the way from about 100 kilometers up to about 400 kilometers in the daytime. The ionosphere puffs up because of incoming radiation. Solar radiation. Here's what the ionosphere currently looks like in terms of the vibrational frequency of the F2 layer. The F to F2 layer. So quite a few low frequency anomalies here on the planet. Let's play we're actually going to play the animation here for once. We'll show both the raw data and the anomalogram because I want to see where the South Atlantic anomaly is currently located as it's been moving around. All right, so here's the raw vibrational frequency. That's megahertz, millions of vibrations per second there in the ionosphere. And South Atlantic anomaly is not sure. Looks like it's still right here near the equator, near the west coast of South America. So it's more like the Central Pacific anomaly at the moment, but hey, them's the facts. Does it mean doomsday? Well, certainly not. We don't exactly know how Earth's magnetic field is even generated, like in a lot of detail. It's a lot of conjecture as to how it actually forms. But here's your anomalogram. This is anomaly in megahertz from a 30-day median. And yeah, the South Atlantic anomaly is somewhere here around equatorial South America on the west coast there. So by the Pacific. There's also a African anomaly, which is right about here near the equator on the west coast of Africa. We do see some turbulence down here as well. So the South Atlantic anomaly moves, thousands of miles throughout the year, folks. We've covered it on the channel repeatedly. But anyway, yeah, that's the anomalogram. This is showing high frequency anomalies in blue, low frequency anomalies in red. That's what the ionosphere is looking like. At least in terms of the 30-day median. Hope that makes sense. It's anomaly in megahertz from the 30-day median. Anyway, let's move to Earth weather. Shifting gears here, and let's put your comments on the screen. Thanks to everybody who's left comments. Don't forget to organize the chat into live chat. Click the top there where it says top chat and click live chat so you can see all the messages. And we're delighted that you love it. Doobie Roller. All right, yeah, cheers everybody. Let's shift gears to Earth weather. That is old data. All right, so how about a nice visible image here of the closest planet? Although let us know if you're viewing the videos from a different planet, solar system, universe, galaxy, multiverse, spaceship, timeline, etc. Let us know in the comments. We may even be able to see them. We may even see your comments. We've got our fingers crossed that the software will function. I know, it's a lot to ask. Don't worry, folks. We're going to have an AI utopia in a matter of 5 minutes. Right after they're able to make a smartphone app that's bug-free, right? Anyway, there's a sunrise over the lovely Atlantic. By the way, if you've never seen the merch shop, check out the merch store. It is linked below this video. SNN Least Busted Name in News. Yeah, there's lots of merch. And, yeah, you want a nice Thor caption this? There you go. How about Thor caption this? Anyway, let's look at the water vapor situation over the U.S. Shout out to our viewers from all around the world. We are going to show the planet's jet streams, as that was a regular feature of the daily space weather videos in the past. It's back. There's our water vapor map for the U.S. A lot of moisture here making its way from the Pacific through Canada and into the Pacific Northwest. As we stated on Friday's video, it's very moist in Washington. And look at all the massive amount of moisture here making its way into Montana. Very, very snowy in Montana indeed. Here's our U.S. Doppler radar map. The Bonsai Express, folks. I mean, check it out. That is a lot of moisture coming in from the Pacific. And it looks like it's rainy in Seattle for once. Not exactly on my bucket list to visit Seattle this year. Although, who knows? Maybe there's a good bike race there. Let's take a look at windy.com. They've got a great mobile app, by the way. Windy.com. We're located in Lehigh Valley, Pennsylvania, if you're wondering. Shout out to our viewers from all around the world. Here is Windy's fantastic satellite map. It takes shortwave radiation data and ties it together with visible satellite data and comes out with these beautiful composite images. It's just spectacular. Some thunderstorms in Mexico at the moment, especially the western portion. Sinaloa. All right. And what's going on in the realm Fremunda? There it is. And wow, lots of lightning. When I say Australia is the Florida of planet Earth, I'm not kidding. As Florida is the lightning capital of the U.S., that is a lot of strikes. By the way, if you want to follow lightning strikes in real time, this site could save your you know what. It's check it out. Let's actually go to the home site. Blitzoltung.org. Oh no. All right, let's try. Lightningmaps.org? Oh, thank goodness. I was afraid lightningmaps.org would be down. This is a real-time lightning map, folks. Yeah, you can actually see where the lightning strikes are coming. This could save your you-know-what. Oh, tell me it still works. All right, here we go. I was looking at Antarctica. Yeah, there aren't too many sensors in Antarctica. What the heck? Can I move the map around? Maybe it doesn't like this browser. But anyway, lightningmaps.org is a spectacular website. What is up with that? There we go. There's a real-time lightning map of the realm Fremunda. And it's not great. Let's check the US one. I just want to see what it shows. Oh, it's showing those Mexican strikes. Anyway, real-time lightning maps, lightningmaps.org if you like. If you're saying, son of a bit turn, where's the lightning going to strike next? It could help with that. We're going to skip forecast. We're just going to show the jet stream. We regularly show forecasts from tropicaltidbits.com, but we're going to skip that today and show the winds. So this is where they blow. These are the surface winds of the central world. Surface winds. It's a windy day on the Mediterranean, especially the eastern Mediterranean, and also in that North Atlantic. Look at the North Sea. Some big surf at Norway. Look at that major offshore wind there at Norway. Probably not a popular surf spot, but there may indeed be some heavy waves. Let's take a look at waves. Ocean waves, significant wave height. There we go. And indeed, there are 35 footers. 35 footers up there off the coast of Norway. So that is, those are some heavy seas indeed. Heaviest seas are over here west of Kamchatka. Look at that. That is a death trap. 45-foot seas. Dude. Yo. To all my Russian surfers out there. Hey, that is, oh my gosh. 45-foot seas, folks. Yowzers. That is bonkers. Anyway, here are the jet streams of the central world. Cold air being injected into Central Europe, as you can see here. Jet streams of the west. Non-existent jet stream right here in the southwestern U.S. No jet stream in that area. Big split here, and then a huge convergence. These winds here in the the western Atlantic, 183 miles an hour, folks. So there is a fast route to Europe today if you're on a plane. Surface winds of the west are looking like this. Surface winds of the eastern world. Strong low there in whatever that is. And here are the jet streams. Very strong jet stream here across the Pacific, the North Pacific. Anyway, let's close this mother out. Some more space weather on the way. In a little over 2 days, expect another CME impact, but it's going to be a minor one. So that's where we're closing this thing down. Thanks for tuning in, everybody who has. Congratulations on realizing the Smash News Network, These Busted Name and News exists. We're just the world's most comprehensive daily space weather content. No big deal. And don't forget to check out our shorts. We are on BikeTube as well. We aren't just on ScienceTube. We're also on BikeTube. And I guess we're a little bit on Aquarium Tube as well. But until next time, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, These Busted Name and News. And until the next coronal mass ejection impact strikes, may that solar wind be at your back.